So this is Leetcode number 115, that is distinct subsequences. So what is done in this question there? First of all, we have the two strings given there. There's a S string and there's a T string there, and we have to return the number of distinct subsequences of S, which is equals to T. So let's summarize this, what is done in this question there. So basically we need to count how many of the ways such that we can form the string T from using the string S. Okay, so we have to simply return what are the number of ways there. Let's say if you are to seeing about this test case RABBIT there, and there is RABBIT. So we have to see in how many of ways we can make this string T using string S there. Okay, so you can see there's a three ways. If you have to select this R, there's a there's a B. Okay, and now you have to take this B, and there's this IT. Okay, so this is one case, and so it means we have to skip that B at a time. For the string 1 you skip this B, for second string you have to skip this B, for third string you have to skip this B. Okay, so since they are at different index, so they are treated as a different, so don't confuse it with by what are the characters are same or not. Okay, so there are the three possible ways in which we can generate a string T using string S, or we can say from string S there. Okay, so if you have to see for this example 2 there, so there's a example BAG, and there's a T is BAG. So how can we make this T there? So let's come to this compiler part there, and I take this part here. So here I have to discuss this, how to do this. Firstly I can say this, and I do one thing here again. Okay, so if we can take this, how to make this BAG. So let's say if we use this B and use this A and use this G. Okay, so this is one of the possible combination. Now we can take this B, this A, but this time don't take this G, we can take this G here. Okay, so this is second possibility. Now let's say we take this BA, but now we don't have to take this A, we skip this A, and let's check there's a if and another A. So yeah, this A and this G. Okay, so this is third combination. And now let's say we don't use this B, we simply go to this B and now take this A there and this G. Okay, so this is fourth combination, and now again skip that B also, come to this B and this A and this G. Okay, so there are the total number of the 5 combination, or we can say the 5 ways by which we can print a number string T using the string S. Okay, so basically this is given in this question. I can again we can say there it is asking me how many ways we can form a string T from string S. Okay, so that is given in the question here. Now come to the intuition part, how to do this question. So we can see one thing there, let's say we have to discuss using this test case there. This BA, let's draw this again so that's to understand it very well. So there's a S string, this is nothing but the B, A, B, there's a G, there's a B, there's a A, there's a G. Okay, and there's another string is nothing but there's a B, there's a, let's say this is start with here, and this is a G there. Okay, so since we know very well, in our previous videos also, whenever we have to compare the two strings part there, so we simply associate with these using two pointers. So here we can take our pointer I there, and here we have to take this pointer J there. So let's say I have to write this is for the point here I have to take the pointer J, and here I have to take I think it can be submerged with it. Okay, so here I have to take this the pointer number I there. Okay, so now coming to this question. So like how to do this. Okay, so now let's say we have to traverse this from the our ending to start, and similarly starting ending to start from the I pointer and from the j pointer, and see like in how many ways we can form that string there. Okay, so now let's say we are standing at this position and this position. Now see, if these are number of the like same, if these characters are the same, so it means if we so we have the choices. Let's say if we take this g, let's say since we know very well, like there are the five combination, or we can say there are the five ways by which we can form this t using this as. So let's say we are standing at here. So now we have the two choices. Either we can take this part, because if we take, okay, so now if we so our j pointer moves there and j becomes this, so now afterward we have to search for this remaining a and b. Okay, means because our the requirement of g is meeting at here. So this is one possibility. Now let's say let's don't not take, let's say we think that we can take the g in our, let's say in our future. Okay, let's thinking, let if we are requiring the g, so thinking let's it can be meet in our future. So if during the traversing we see this g can be meet here. Okay, so there's a possibility that we do not take g from here and not take the g from here, and there's a remaining a and b from here and here. So there's a g, there's a there's a b. Okay, so there's a requirement can be meet. Okay, so that's the case. So okay, and now let's say this is the condition when our characters are matched, means we have the options of taking, non taking. And let's say there's a situation I arise in which we don't have an option, means there's a character not match. So in that condition there's only one thing, means we do not we not take in that condition, because the taking condition is not possible here, because the characters is not matching. So we don't have any of the choices here. We must go to our pointer move, or we must not take here. So like let's say I have to read here, I have to summarize this. Here's the two conditions there. Either our characters are matching there, or okay, so like so here the two condition, either take or either not take there. Okay, so these are the two things. And another condition, if no matching. So in that condition what we do simply, so here we have not here we have no choice of taking that part. Here we are trying to seek whether we can meet this requirement in our future, means during the traversing maybe it is possible to meet this requirement or not possible. Okay, so that depends on our string. Okay, so like this can be understandable in this question where very well. Okay, so like so at every step we have the choices there, either we have to take or not take. So means whenever the choice exists, so recursion comes in picture. Okay, and it's like since recursion comes in picture, means so now we need to define the we can say the meaning of the state, because for the recursive state we have to define this. So like what's the definition of our f of ij? So this is nothing but this is simply the number of ways I can say to form the t which is using the j, I can say this j, using our s of string, that is nothing but the till index I. Okay, so this is the definition of our f of I of j. And like what needs to, in our question we simply need to find this. Okay, so what we need to find, we need to simply find this, and there's nothing, this n and m nothing but this length is of n and this length is of our m. Okay, so this is our question. Like I again explain you like how to do this. Let's say if I explain for this test case here, let's say okay, now let's say I'm talking about this using the example of this test case. So here's nothing but the s is equal to b, then a, then b. Okay, and there's another string that is nothing but the b, then a. Okay, so now we are standing at the pointer, here is our I pointer there and here is our j pointer there. Now we we have to see whether the characters are matching or not matching. Since this character not matching, so we don't have any of the much choices. There's only constraint is we are not able to take this. Okay, so in that condition we moves our I pointers to here. Okay, so now comes check to see whether take or non take. Okay, now we have the two choices. If we have to take this position, means our this requirement is meet. So for that position we simply move our j pointer also there, and I pointer is simultaneously move there. And if we don't take and we are expecting that it might be meet in our future, okay, like these are the possible cases, but maybe it is not. Like I can write it here. First of all, I can, this is for our I there, and this is for j. Okay, so like what I'm trying to say, if our characters are matching there, if characters, I can say characters are matching, so in that case what I'm trying to say there, so we have choices. I can see we have the choices, either take or not take. Okay, so like whenever I'm trying to say take, so in case take, what we do mean we meet our, we can say we meet uh, our t of j. Okay, so in that case what we do simply, since like we have to take this position, so our I pointer is updated here, and since we meet, so our j pointer also update. So this is a condition for the take pointer, we can say the take part. And let's say if we don't take and we are expecting, so we say don't take. So what it means, it means we are expecting to meet in future, we can say. So basically this is the meaning of, because this is our thinking process. Okay, and now it is possible that it is meetable in the future or not. Okay, so in that condition only our I pointer is updated and j pointer is still at stands at there. Okay, so like this I'm trying to explain here. Okay, so one thing also, like okay, I explain it again. Okay, I explain here. See there, if I'm talking about the why, okay, let's say I'm trying to say what are the possible base case for this. So the first base case, what we have to do in the first base case, now see like what are the cases we can arise in there. Okay, so let me see there, like we are using I index for the mapping or for the traversing along the s string there, and j for moving along the t string there. Okay, now let's see what if our j is become the j is less than 0. So what it means, so simply this is our required, and this is like from where we have to trying to find it. Okay, we simply needs to find out all of the characters that we have to move this j till it goes to 0. So if our j is less than 0, so it means we can simply say like we can formed our we can say our entire string t. So that is our desired dream there. Okay, so in that case we simply return once, because that is our required demand for this question. So in case it meet, so we simply return one case. Okay, so that is our the base case number 1. Now coming for the base case number 2. So what what's the thing for this? So in this case we can say if our i's become the less than 0. Okay, and since I have to calling j is less than 0, so like it is assumable, or it is like common sense that here is j is always greater than equal to 0. Like I am talking about this case because it j is less than 0, case is already handled in this case. Now if our let's say our I pointer is become exhausted there and j is still there, so what it means, we can say x is exhausted but t, we can say is still remaining there. Okay, okay, so this case since we are not able to meet our requirements, so in that case we simply return 0. So this is our two crucial base case for this, means there's no way to form our required, or we can say our remaining string there. So now we can see here the definition of our our recurrence state there. So here we can also like write this in our way, like how to do this. We see here this, if our characters are matching, we simply use the take or non-take case, and if our character is not matching, we simply we have the only one choice, that is non-take. So now I have to simply write the recurrence relation. So how to write this? So it is nothing but it's simply if our characters are matching, so in that case we have to simply take or non-take. So I've explained you again in there's a BAB case there. Okay, so what we have to do, if our I explain here, so see this part, if the characters matching, if characters are not or matching. Okay, so if our characters are matching, so what means, let's say we have the two choices, either we take or not take. If we take, so means our I pointer and j pointer both are updated, so that's why we take this case. Okay, another thing is, let's say we are not taking and we are expecting that it can meet in our future cases, so that means our I pointer is updated but j pointer stands here still there. Okay, so in that case our f of I minus 1 there, but j is remaining the same. Okay, this is if match, we can say if match condition. Okay, so this is for the match condition, and in else condition what we can write there. So here's, it is nothing but we can simply write that our since we have to skip that part, means our j is still there but our I pointer is moving there, because why we don't move j, because we are not founding that character there. Okay, so if not matching there. Okay, so like this is our whole question there, and why we do plus, because we are trying to find what are the number of ways. And there's, I also do this dry run for this case, there's a s string, there's a t string, so you can simply see what is the output for here. So here's output is nothing but simply 1 there. Why 1? Because there's only one thing, this b and this a, so that is our t. There's only one way possible to finding this t from this string as there. Okay, so now coming for this, since we have to call for the f of n minus 1 comma m minus 1 there, as I already done to there. Okay, and there's n for size of s and m is size for t, so I have to call for f of 2 comma 1. Okay, means I have to start I from here and j from here. Now see, these are characters b and a, since these are not mutable, so in that condition only cases we have to skip that part, or we can say we have to not take. So we have to call for this f of we have to call for this f of I minus 1 comma j, so that's why f of 1 comma 1. Now we are reaching at this and this, so here the characters are matching a and a, so now we have two condition, either take and non-take. Okay, so in the take condition both our pointers are movable, in non-take condition only I pointer is movable. Okay, so in take condition there's a now condition state arises f of 0 comma 0 is still b and b, again the 0, again we have two choices, take or non-take. In take condition it become f of minus 1 minus 1, in the non-take condition it become f of minus 1 comma 0. Now see this condition carefully. Here our I is exhausted, means our string s is extinct, but tree is still remaining, so in that case there's no way possible, so written no. Here again the case is when our our j's pointer is less than 0, means our we complete our requirement, so that's why written simply 1 there. And now for this string there, now come for this f of 0 1, means our I pointer is at here and j pointer is at here. So now since there's not possible, because b and a are not possible, and by this it has to not skip, so our I pointer again move there and I is become less than 0, so that is no way possible from here. So only one thing is possible from here, so means this is a follow path, that is our desirable path there. But it doesn't ask me for our the string there, so we don't have to bother about it. Okay, so the coming to the coding part there. So how's the coding for done here? So this is the brute force here, you can see very well here, this is our main function here. We have to simple our solve function, this is for the s size, this is for the t size, and how it is done here. So we have to simply pass our index s and index t. We can use the I and j also here. So if our I already explained the base case, if our I is less than 0, means we are it is index j, so if our j is less than 0 means we have to meet our requirement, simply return 1. If I less than 0 means we are not able to meet our requirement, and in the future it is not possible because it is exhausted, so return 0. Now both cases, if the characters are matching, so this is case, if the characters are not matching, means this is the case. Okay, So like you don't have to write explicitly else condition, because this condition follows, so return for this, otherwise return for this. Okay, and since this is for the brute force, now coming to this, like what's the time complexity and space complexity. Since we know in these questions every characters or at every index we have the two choices here, so means at for this there's a total 2 power n choices, there's a total 2 power m choices. Okay, so but it is exponential time complexity, so it gives a TLE. So I can see it, since it gives a TLE there, so here we can say there. Okay, because in power of the multiplier they are the addable there, and we can say there's n plus m, because of all of the states in the worst case it use the recursive state, a recursion is stack there, is stack space there, so that's why for this, since this is exponential it is not acceptable. So go to this part. Now during the this question dry running for this part, if we are taking for the many of the extra big case there, so we see one thing there, that there are the some of the states that are repeating again and again. So to avoid that recomputation again and again, we simply have to store that values. And how to do this? Using this some of the kind of the storing. So for this we have simply use the db vector. Now come for this question. So this is our memoization version, because we can use the dp version, it is acceptable. Here our time complexity is nothing but the of n into m there, and here's space complexity is again it is n into m there. So this is for the dp, and there's again n plus m there, and this is for using the recursion stack there. Okay, so like this is our question there, and you can see one thing here also. Okay, like okay, so don't have to worry like this, since this is a constraint is very low, but it still it is not acceptable of brute force there. Okay, so that is our question. We can see here this is for O of n into m there, and this is okay. So that is our question.